Welcome to this explainer where we're going to put on our developer hats and look at how autonomous agent loops can completely, literally revolutionize your entire coding workflow. Look, if you've ever felt like there just aren't enough hours in the day to write, test, and debug code, well, you're definitely not alone. But what if your dev environment just didn't sleep? What if it was actively squashing bugs and solving complex problems while you were literally dreaming? Today, we're going to look at exactly how to make that a reality using intelligent, iterative agents. Okay, let's just quickly breeze through the roadmap here. We'll be looking at the 24/7 autonomous developer workflow, iterative learning in simulations, a fun model showdown between Opus and GPT-5.5, safe scripting practices, installing Hermes, and finally, the wild future of autonomous development. All right, let's kick things off with Section 1, the 24/7 autonomous developer. So, to really get this, we've got to completely rethink how a developer actually spends their time once AI takes over the heavy lifting, the grunt work. The whole traditional model of just staring at a blinking cursor for 8 hours? Yeah, that's rapidly becoming obsolete. The real magic, the absolute game changer here, is that your day is now for high-level management, right? You're acting collaboratively with the AI, you set the parameters, you design the goals, but the night? The night is for automated agents running simulations until 5 in the morning. When you log off, you just tell the agent to grind away, testing and iterating sequences. And then you wake up, and instead of a massive to-do list, you literally just have a finished results report waiting for you with your morning coffee. Before we get into the crazy results, let's quickly define what this loop actually is and why it's so incredibly powerful. An autonomous agent loop isn't just an AI spitting out code once and calling it a day. No, it's a complete, closed-loop feedback system. The AI gets a prompt in plain old English, writes a specific logic, executes it, and, here's the absolute crucial part, it receives a diagnostic report of its own performance. It sees what went wrong, and then it rewrites its own code to get a better result, over and over again, entirely on its own. It's like having a junior dev who literally never gets tired. Moving right along to Section 2, iterative learning in agent simulations. Let's look at our gravel gravity well simulation. We needed a way to truly test if these models are actually learning or just, regurgitating their training data. So a custom physics simulation was built. Picture a playing field with 4 gravity wells, essentially 4 suns. These little blue ships have to navigate this space, conserving their limited fuel and momentum, all while trying to stay inside this moving target circle. Now, this step-by-step loop shows you exactly how the troubleshooting works in this scenario. The agent writes the initial flight script, it runs it. If the ships crash into a sun or the code just straight up breaks, you don't step in, you just feed that exact error message right back to the agent, and it tries again. It learns the physics entirely through trial and error. And this brilliantly illustrates the learning curve. It's wild to watch. We're talking about transforming a completely chaotic first run into an incredibly optimized flight path. In iteration 1, the models make total rookie mistakes. They burn all their fuel immediately trying to accelerate. They fly out into the deep, dark emptiness of space, and yeah, they usually just crash directly into the suns. But by iteration 20, man, it is a completely different story. They become absolute ace pilots. They learn to just gently tap their thrusters, they anticipate exactly where the target is going to be, and they rack up massive points. Okay, Section 3, Model Showdown. Opus versus GPT 5.5. Now, what's really interesting is what happens when we pit these AI models against each other in a one-on-one duel. Instead of testing them in a vacuum, we threw them directly into the arena together for a 10-iteration live showdown. They were each fed their own specific diagnostic reports at the same time, proposing changes and iterating side by side. And wow, GPT 5.5 High pulled ahead significantly here, winning 7 rounds to Claude's 3. GPT locked in a really stellar final high score of 68, leaving Claude Opus trailing way behind at just 43. Let's break down exactly why this performance gap exists, because it's super revealing. What's absolutely fascinating is that GPT 5.5 actually had a terrible start. I mean, it crashed 2 of its ships right out of the gate in round 1. Just a total disaster. But its architecture makes it excel at long-horizon planning and complex project management. It absorbed that massive failure, corrected its logic, and scaled its performance beautifully over time. Claude Opus, on the flip side, learns very quickly right at the beginning, but it kind of hits this early performance ceiling where it just struggles to break past a certain score. Still, the fact that iterative diagnostics allow both models to independently troubleshoot their own logic is just mind-blowing. Up next, Section 4, Safe Autonomous Scripting Practices. Look, handing over the keys to an autonomous script can be super risky, so we absolutely have to talk about containment. Because letting an AI run completely wild on your machine without any oversight, that is a recipe for disaster. If you're going to let an AI run uninhibited for 48 hours without any confirmation prompts, you are literally playing with fire. The official systems give you massive warnings about this, explicitly stating that bypassing approval sandboxes is extremely dangerous. And they're right. When you remove those safety rails for a 24/7 loop, an AI could easily execute commands that wipe your folders, break system architectures, or expose sensitive data. So, here are the non-negotiable best practices for minimizing that blast radius. If your agent goes rogue, we want your primary hardware to stay perfectly safe. First rule: never ever run autonomous agent scripts that bypass confirmations on your main local machine. Don't do it. Instead, contain the blast radius by spinning up a remote virtual private server, a VPS. It's someone else's hardware, securely in the cloud. Take it a step further and run those environments inside Docker containers for really isolated sandboxing. Make sure you connect securely using SSH rather than running anything locally, and definitely protect your credentials and API keys with a password manager like 1Password. Basically, if the AI causes a total system meltdown, you want it happening isolated on a server 1,000 miles away, not on the laptop that holds all your tax documents and family photos. All right, Section 5, installing Hermes on Ubuntu. Next up, we are going to walk through the exact steps to get the open-source Hermes Agent up and running safely. Hermes is fantastic. It features persistent memory and actually auto-generates its own skills over time. It's a real game changer. By following these exact steps, you bypass all of the UI clutter and install the agent like a true developer. First, you'll want to provision a VPS with a clean installation of Ubuntu 24.04 LTS. The LTS, or long-term support, guarantees stability, which is exactly what the devs test against. Next, generate a super secure root password. Open up your terminal of choice and SSH securely into that remote machine. Finally, just run the Hermes manual install command. Oh, and a quick pro tip here, avoid using sudo for this unless the agent specifically needs high-level administrative tasks. Keep those privileges restricted, for sure. And here is a golden rule to remember. If things break mid-run, and they will, don't fix the code yourself. Just simply paste the error message or the diagnostic report back into the agent's chat and let it rewrite the broken logic. Honestly, this is the most profound mindset shift for a developer. When you hit a weird syntax error, your absolute first instinct is to dive into the codebase and patch it manually. Resist that urge. Copy the terminal error, hand it right back to Hermes, and let the loop do exactly what it was designed to do. Which brings us to our final section, Section 6, the future of autonomous development. Let's zoom out for a second and look at what this all means for the future of our industry. We've gone from AI acting as just a fancy autocomplete tool to AI acting as a full-time, tireless coworker. So how will this continuous, iterative agent learning revolutionize complex, long-horizon project management? Well, imagine a near future where evolutionary Darwinian learning lineages allow these agents to solve massive, multi-week software projects completely autonomously. We're heading toward a system where you don't just run 20 iterations in a night. You run thousands of them over a week. The agents that write the most performant code pass those traits on to the next generation of scripts. We're talking complex physics engines, massive database migrations, whole application ecosystems, all developed through guided, accelerated evolution. Ultimately, the developer's role is radically shifting. Your job won't be manually writing the code, it'll be managing vast, open-source agent ecosystems that iterate 24/7. You're transitioning from being the bricklayer to being the architect. And honestly, I hope this explainer leaves you incredibly hyped to start building your own autonomous setups. The tools are out there right now, they are ridiculously powerful, and they are standing by ready to work the night shift. So the only question left for you is, what massive project are you going to task your autonomous agents with tonight?